We are going to sketch this function using these guidelines. So we're going to start with part A, determining the domain of the function. So here we have a rational function and we can't let the denominator equal 0. So we want to figure out what is going to make the denominator equal 0. So if we add 1 to the other side and take the square root, we get plus or minus 1. So there are two x values that would make the function undefined, which means the domain of the function are x's in the interval negative infinity to negative 1, then negative 1 to 1, and then 1 to infinity. So that is going to create asymptotes in our function, which we'll get to on part D. Now let's look at B, finding intercepts. So if you want to find intercepts, so we're going to plug in 0 for x to find the y-intercept. And that's going to give me 0 over negative 1, which equals 0. So I plugged in 0 and got 0. So 0, 0 is an intercept. And then we're going to plug in 0 for y. So if I multiply x squared minus 1 over to the 0, I just have 0 now. Divide by 2, 0. Take the square root, 0. So I plugged in 0 for y and ended up getting 0 for x. So I ended up getting the same intercept both times. So there's just one intercept for x and y, which is 0, 0. Then part C, looking for symmetry. Now, symmetry isn't necessary, but it just could make the process go faster. So let's test symmetry. You test that by plugging in negative x. Plug in negative x for your input. So each x value I plugged in negative x. And then what happened is the square on the negative x cancels the negative when we simplify this. If I simplify this, that cancels the negative. And I'm back to the original function. If you get back the exact original function, then it's even. So if this is even, it's symmetric to the y-axis. So that could make it faster. We'll talk about that later when we start to sketch the graph. D, part D, we're looking for asymptotes. So let's start with horizontal asymptotes. So when we're looking for horizontal asymptotes, we are going to test the infinities. So we're going to test positive and negative infinity. And remember, to do that, we, in the past, divided by the biggest x on the bottom. So we are going to divide by x squared. This is only when you approach infinity. So the x squareds cancel, those reduce, and then once you plug in infinity for the x value, you end up getting 0 there, so you get 2 over 1, which is 2. So the limit as we approach infinity and approach negative infinity is 2. So this is my horizontal asymptote. Vertical asymptotes, you look at the domain, and they should be 1 and negative 1. So we know where they are, but we need to know what happens at those values. So let's look at negative 1. We're going to approach negative 1 from the left, and we're going to approach -1 from the right. So we know -1 is an asymptote. We just want to know what happens there. Like in the past, we know that it's an asymptote. So all we got to do is just test a number and decide whether it's going to be positive or negative. And so here's my original function to look at. So if I plug in something to the left of -1, something smaller, say -2, I'm going to get a positive on top, and I'm going to get a positive on the bottom. So this is going to go to positive infinity. If I test something to the right, say 0, well, 0 doesn't help me because that doesn't tell me positive or negative. It'll give me 0. So let's test something smaller, like -1/2. So -1/2, that's going to be positive. And then if I plug in -1/2 right here, I would get 1/4, and I'd subtract 1 from it, so it's going to be negative. So that's going to give me negative infinity. So that's -1 as an asymptote, but we also have +1 to look at. So let's look at +1 from the left and from the right. So if I think of something smaller than 1, say +1/2, that would give me a positive on top. And +1/2 would do the same thing down here. I'd get 1/4 minus 1, so negative. So negative infinity. And then positive, or 1 positive. So let's say maybe 2. That'd be positive and positive. So positive infinity. So we've got vertical asymptotes at 1 and -1. All right. So we've gone through A, B, C, D. Now we're going to look for intervals of increasing and decreasing, which to do that, you want to find your derivative. So we've got the function 2x squared over x squared minus 1. We're going to do quotient rule with that. So derivative, it would be low d high, which would be 4x, minus high d low, derivative of the bottom is 2x, square the bottom, and away we go. So that's what we have so far, and we're going to try to simplify the top. So if you distribute your 4x, we have 4x cubed minus 4x minus 4x cubed. And then we are going to collect like terms. So my 4x cubes cancel. And we end up getting negative 4x over x squared minus 1 squared. Okay, so looking at this, we want to identify our critical numbers. So if you look on top, if you set the top equal to 0, you get 0. And then on the bottom, we have the same thing that we had before. We are going to have plus or minus 1. So these are my critical numbers that we're going to make intervals out of. So let's make our interval chart. So we're going to have negative infinity to -1. Then we're going to have -1 to 0, 0 to 1, and then 1 to infinity. Okay, then we've got two factors that make up the derivative. So we've got negative 4x, and we've got x squared minus 1 all squared. Now, anything that's squared will always be positive. So we already know this. And all we got to do is figure out the negative 4x and then multiply them. So if I plug in a negative here, I'm going to get a positive. If I plug in a negative, I get a positive. Here I'm plugging in a positive, I would get negative, and a positive is going to give me negative. So when I multiply these, my derivative is positive, positive, negative, negative. So that tells me that it's increasing, increasing, decreasing, decreasing. If we want to make a number line, so we're going to see increasing all the way to 0, and then we're going to see decreasing after 0. All right, so we did increasing, decreasing. Now max and mins. So we see there's only a max or a min at 0. There's a maximum at x equals 0 because it went from increasing to decreasing, which we see right there. So if we plug in 0, we already plugged it in earlier, 0, 0, max at 0, 0. So that is part F. G, continuity. So for that, we're going to need our second derivative. Let's switch to a new page. So second derivative. Now our first derivative is negative 4x over x squared minus 1 squared. Right there. All right. So my second derivative is low d high, which would be negative 4, minus high d low. So now the bottom here is a chain. So we're going to have 2, leave the inside alone, and then take 1 away from the exponent is 1. And then we do times derivative of the inside, which is 2x. And then we square the bottom, which will now be to the 4th. And then let's simplify this. So if I FOIL this thing, I end up getting, actually don't FOIL that, because what I see here is x squared minus 1. I have it in all 3 terms. So actually, let's cancel one of these x squared minus 1s. So that'll cancel that one altogether. That will cancel one of these, so get rid of the square, and that'll change this to cube. So we just factored out and reduced an x squared minus 1. So now all I need to do is distribute a negative 4 onto that. And then if we multiply all these things together, I'm going to have positive 4 times 2 times 2, so 16x squared. We can put our x squareds together. All right, so what we see here then is if I set this equal to 0, the top, if I subtract 4 and divide by 12, I'm not getting anything. So, because it'll be imaginary, square root of a negative. So that's not leading to anything. And then the bottom, we still have that x squared minus 1. So that gives me that plus or minus 1 again, which could be inflection points, where it could change concavity. So we're going to make a chart and split it into intervals. So we've got negative infinity to negative 1, negative 1 to 1, and then 1 to infinity. We've got this, well, 2 factors here. So we've got 12x squared plus 4, and we've got x squared minus 1 cubed. And when you multiply those will make your derivative. So if I plug in something like negative 10, this thing, if you look at it, it's squared, so it's positive. 12 keeps it positive, and then you're adding to it. So this is going to be positive every time.